terminal branches of those blood vessels serving this area. And so we have from the internal carotid artery, the anterior cerebral arteries, and the middle cerebral arteries, and from the vertebral via the basilar, we have the posterior cerebral arteries. The anterior and the middle get about 80% of the cerebrum, while we're seeing that the posterior circulation from the posterior cerebral artery is the other 20%. So what we want to do is lay over these numbers the blood flow. So sort of taking what we saw with this picture and this picture and applying it to the numbers. So let's start with some easier ones. Let's start with, say, 17 and 18. So we have our primary visual area, we have the secondary visual area, 17 and 18. What's going to serve those areas?
Posterior cerebral artery?
Posterior cerebral arteries. So the posterior cerebral arteries are going to serve those areas. Okay? So if you have a problem with the posterior cerebral artery, you may have a problem with vision.
Okay.
Let's do 41 and 42. 41 and 42, this is dealing with auditory. What's going to serve 41 and 42?
Middle cerebral.
Middle cerebral. Because remember that middle cerebral is coming right out that longitude, that lateral fissure or sulcus right out here, and it's going to serve this area. Okay? That brings in the idea of 44, 45, broken speech area. What's going to be serving that?
Is it also middle?
That's also middle. It's also going to be middle. What about 9, 10, and 11, that prefrontal cortex? What do you think that's going to be?
Anterior.
A little bit of anterior, but also a little bit of
Posterior?
middle, a little bit of middle. So it's mixed. So this, you're going to have the anterior cerebral arteries coming out and wrapping around, but at the same time, middle cerebral is also going this direction, so it's going to be a little bit of a mix. So it's 17, 18, 41, 42, 45, 46, or 44, 45, 9, 10, 11. Okay, let's do 4, that primary motor area. The primary motor area, what do you think that's going to be?
Anterior.
A little bit of anterior and
Middle.
middle. A little bit of anterior, a little bit of middle. So anterior is going along the longitudinal fissure, sending branches up and over the top, so it's getting a little bit through this area here, but then middle is going to come up this area. And that also applies for 312. 312 is also going to be mixed. It's going to be a little bit of anterior and a little bit of middle. And that brings up the idea of the homunculus. Okay, so here's your longitudinal fissure. This is where your anterior cerebral arteries are coming. Anterior cerebral arteries send their branches up and over the top here, while the middle is sending its branches up this way. So at some point, there's a changeover between the supply. Remember, this area is here is the paracentral lobule. That paracentral lobule and a little bit over the top is going to be served by the anterior cerebral arteries, while everything out here laterally is going to be associated with the middle cerebrals. So if I had, say that I had an issue with movement or sensation of my lower limbs, movement or sensation of my lower limbs, what artery might you think might be involved? Anterior cerebral, because the anterior cerebral is going to get lower limbs and everything up to about the hip. So about this region right here, we have a little bit of crossover between the two, but when it comes to the lower limbs, when you think about the cortical area, that's going to be the primary motor areas for it and the primary somatosensory areas for it, that's going to be associated with the anterior cerebral.
So when you say that you have a problem, it's your problem moving it is not because you have a problem with your actual veins and arteries of your leg, but of your nerve.
Yeah. So if one of the many clinical issues that could be associated, so say that you had a stroke and it involved the anterior cerebral. So if you have a stroke with the anterior cerebral, you may contemplate there may be an issue with movement of the lower limb and then also with sensation of the lower limb. Everything's intact on the lower limb, it's just that the brain is unable to communicate with it.
And is this like contralateral too?
Exactly.
Oh, okay.
So let's add a little bit more fun to it. If I say that there's a stroke or some sort of issue with the right anterior cerebral, am I gonna have problems with my left or my right lower limb? Left. So it's contralateral.
But is that a problem with the left, or is it, that's where you'll see the deficit?
That's where you'll see the deficit.
And that's how it was last time, right, when we were talking about the.
What was the question?
Yeah, and it's gonna be the same way with vision as well. So what we'll see when we do special senses is that the primary visual area, this primary visual area, you have two of them, one on the right, one on the left. This primary visual area on your right is going to get all the information from the left half of your visual field. So if you are having a problem with your right posterior cerebral artery, you may not see anything on the left side of your visual field. It's all contralateral. It's all contralateral. Okay. But out here, this is on the middle cerebral. So if we talk about the upper limbs, so say we have a problem with the middle cerebral artery. If we have a problem with the middle cerebral artery, we may have an issue associated with movement of the upper limb or with movement of the face, movement of the tongue. And so it's about here around the hip, a little bit of the trunk area. This is where it switches over. And so it's both sensation and motor, okay? So you need to realize that about this area right here, there's a changeover to the supply of the cortical areas. Yep.
Sorry, I have another question.
Okay.
So if you had like, is it the reason why you're droopy on one side of the face when you get a stroke, is it because it's typically the middle cerebral artery, or is that just another?
It's just I don't know what the rates are for which ones are involved. A lot of times, it's involved with the facial nerve and having an issue with the facial nerve. It could also be that there is a problem with the middle cerebral. Yeah. Yep.
Could you just restate what you said again about the changeover from sensation to motor that occurs?
Okay, so when you look at the blood supply to the cortical area for the motor area and the sensory area along the cortex, so what is going to control skeletal muscle around the body and what's going to be able to allow you to perceive sensation, there is two arteries that are going to serve those areas. Anterior cerebral is going to get the paracentral lobule and everything a little bit over the top here to about the hip and trunk area. So around the hip area, there's a switch over. Then what we see is this outer lateral portion, which is the upper limb and the face. This is going to be associated with the middle cerebral. So if you have a problem with your middle cerebral, you may have a problem with your upper limb. If you have a problem with the anterior cerebral, you may have a problem with the lower limb. And that's both sensation and motor. So that's why it's important to understand the homunculus. Remember that if you're trying to remember what the different parts are, think about the homunculus standing in the longitudinal fissure. He pops his head off and then dives over the side. So you're going to have the lower limb and that paracentral lobule, then you're going to come up over the side and heads over there on the lateral portion. So the next couple images are just going to kind of allow you to figure out what we're looking at in terms of some images. And so if we see this, what do you think this is coming up?
Internal carotid.
That's your internal carotid, it's going to be your internal carotid. And you see that there's this branch of the internal carotid that's going up and over something. What do you think this branch is? Anterior cerebral. What's it coursing over?
The corpus callosum.
The corpus callosum, and it's sitting in what fissure? Longitudinal fissure. Sitting in the longitudinal fissure. That means this coming out towards you, what do you think this is?
Middle.
Middle. That's going to be middle. Okay. This kind of hits home a little bit better to show you that from an anterior posterior view, and so you can see that the internal carotid, no branches in the neck, no branches till it gets up inside the skull. And remember, it's going to come up, it's going to go through what canal?
Carotid
The carotid canal, go through what? Foramen?
Foramen lacerum.
Foramen lacerum, good. And we then see the two terminal branches. One's gonna go towards the midline, of course, up and over the corpus callosum, so this is our
Anterior.
anterior. One heads out laterally, so this is the middle cerebral. And we see there's these two blood vessels coming together about right here to form this. What do you think these two blood vessels are?
Jugular?
See them coursing up through the neck.
Oh, vertebral.
They're the vertebrals. So these are the two vertebrals. They come together at the base of what portion of the brain? Is it the medulla? Is it the pons? Is it the midbrain? Pons.
Okay.
So you know, when you see these two come together, you know the pons is sitting right in this area right here. So they come together at the base of the pons. So this is going to be the basilar, and then the basilar is going to come up, give off a number of branches, and then it's going to have its terminal branch. And so what is this? What's the terminal branch of the vertebral via the basilar? Is it the anterior, middle, or posterior? Posterior cerebral. So this is posterior cerebral heading posteriorly. And you can actually see both of them because you have a crossover. You have a little bit of a crossover between the two of them. Well, this is the end. Sorry, I should say it more this way. This is the end of the basilar, and then the basilar is going to split into the two different posterior cerebrals. These are the two posterior cerebrals on the left. So this is showing you sort of the same idea again, but a little bit more from an anterior-posterior view. And so these are your two vertebrals. We're coming up to the base of the pons. You know the pons is starting right here. So this is the basilar. Here's the basilar coming up, and here's the two posterior cerebrals, which are the terminal branches.
Is there ever a time where you would see both the posterior and the middle in this type of angiogram?
Yes. So remember, normally you don't have a lot of crossover. Normally you don't have a lot of crossover through the posterior communicating, this being the anterior circulation, this being the posterior circulation. But say that you had some sort of issue. Say that you had an occlusion that's built up over time here. This would enlarge, and this would actually be served more by the middle. So you could have, or from the internal carotid. So if you put dye into the internal carotid, you would start seeing the posterior cerebral, for example, or vice versa if there was an issue. Here, that would circle of Willis. But normally you don't see a lot of blood exchange between these two areas. Okay. Any questions? So this is spinal cord. This is lesson 28 in the textbook. These are the different objectives and questions to keep in mind as you go through this particular content. And remember that this lesson is split into two parts. There's lesson 28, this one that I'm going to go through. There's also the lesson 28 that says continue. When you go to Carmen page, that continue part is dealing a lot with these tracks associated with the spinal cord, and Leslie's going to do that in the lab on Monday afternoon. So when we think about the spinal cord has a function as a two-way conduction pathway. It's going to bring information up to the brain, information down from the brain. It also is a major reflex center. So there are reflexes that are initiated and completed at the level of the spinal cord. And as we know, the spinal cord is going to develop from the posterior portion of the neural tube. So it's developing from the posterior portion of the neural tube, or caudal portion of the neural tube. And in embryos, we're actually going to see that the spinal cord fills the entire vertebral canal. Remember, the spinal cord sits within that vertebral canal. And in embryos, we actually see that spinal cord filling the entire vertebral canal. But something happens during embryonic development. Remember when we looked at the development of the brain and development of the skull, we said the skull grows very slowly and the brain grows very quickly, and so it has to take on that interest, the telencephalon especially has to take on that very particular growth pattern, and it has to create gyri and sulci so it can get more surface area because it's growing so quickly in comparison to the bone. It's the opposite when you look at the vertebral canal and the spinal cord. The vertebral canal is actually growing very quickly, while the spinal cord is not. And so although in embryos the spinal cord fills the entire canal, we're actually going to see that the spinal cord in adults only goes about 2/3 of the way down. So your spinal cord ends around the L1, L2 level. So in embryos, at first, the spinal cord fills the entire canal. However, with the vertebral canal growing faster than the spinal cord, in adults, only 2/3 of the vertebral canal is filled by the spinal cord, and we see the spinal cord is approximately 18 inches in length and ends at the L1, L2 level. So we're going to see the spinal cord extend from the foramen magnum, where it's attached to the medulla oblongata, and come down to about the level of L1 or L2. And remember, it's sitting within the vertebral canal, which is formed by successive vertebral foramina lining up. That spinal cord is going to come to a tapering end, sort of like an ice cream cone. It comes to a tapering end. That tapering end is called the conus medullaris. So it's going to taper, and that tapering end is called the conus medullaris. So think of an ice cream cone. We're going to see that the meninges that were associated with the brain are also associated with the spinal cord. And although the spinal cord ends at the L1, L2 level, those meninges are going to continue the whole way down through the vertebral canal. So coming off the tip of the conus medullaris is going to be the pia mater. And so that pia mater is going to extend all the way down, along with the dura mater and the arachnoid mater. But that extension of the pia mater is called the filum terminale. Filum terminale. So the filum terminale is just the pia mater that's continuing on inferiorly within the vertebral canal. And we're going to see that all the meninge layers are going to terminate inferiorly about the level of S2. So about the level of S2, we're going to see all those meningeal layers terminating. And it's going to end up attaching to the coccyx and as part of the coccygeal ligament. And it helps to then inferiorly anchor the spinal cord. So if you think about the filum terminale and the fact that it's going to end up anchoring to bone in the end, that filum terminale is going to be helping to anchor the spinal cord inferiorly. Well, even though the spinal cord ends at the L1, L2, you know that 31 times on one side and 31 times on the other side, we have our nerve roots coming off to form our spinal nerves, 31 pairs of them. So although the spinal cord ends at the L1, L2 level, we still need to have those roots extending down to get to the intervertebral foramina or such to get to their exit points. So that collection of nerve roots that goes down inferior to the conus medullaris is going to be called the cauda equina, the horse's tail, the horse's tail. So it looks like an actual horse's tail. We'll take a look at a couple of those, and you'll also see that in the laboratory. And we're going to see that it's going to run through the lumbar cistern, which is just an area of a lot of cerebrospinal fluid. So it's in that subarachnoid space running through that.